Today we're going to learn about congruent triangles. I'm going to keep today's note sheet a little shorter on the video end because I posted 2 additional videos on my website that also go over similar topics and they have very good examples to look at. So I'll keep this video short. We'll go through just a couple examples and then you guys can watch those extra videos if you need to. So there's 4 different postulates we're going to go through. And the postulates deal with sides and angles of a triangle. So these 4 are the only 4 that prove to be true, and you'll see what I'm talking about as we go through them. So the first one is called the side, side, side postulate, and this says that if 3 sides of one triangle are congruent to 3 sides of another triangle, then the 2 triangles are congruent. This means you don't need any other information. All you need to know is that you have 3 sides between 2 triangles that are congruent, and you can automatically say, in this case, triangle GHF is congruent to triangle PQR. And when we give a reason why we know that, we would say by side, side, side. Okay, we don't need to know anything about angles. Knowing that the 3 sides are congruent is enough information to prove the triangles are congruent. The second one is called the side angle side postulate. We abbreviate it as SAS. This postulate says if 2 sides and the included angle of one triangle are congruent to 2 sides and the included angle of another triangle, then the 2 triangles are congruent. So looking at the examples, we have a side congruent to another side, the included angle between the other side. So the included angle means that the sides of the angle, the rays that form the sides of the angle, are your congruent sides. If you circle the sides and you say it in order, you would say side, angle, side. So having this small amount of information would prove to be true that both triangles are congruent to one another. So we could say triangle BCA is congruent to triangle FDE by side, angle, side. And again, when you're using side, angle, side, it has to be a side, the included angle, and another side. The 2 sides are the sides or the rays of the angle. The third postulate that proves to be true is called the angle side angle, abbreviated as ASA. And this says if 2 angles in the included side of one triangle are congruent to 2 angles in the included side of another triangle, then the 2 triangles are congruent. If we look at the diagram, we have an angle congruent to an angle, another angle, and the included side, so the side that's between those 2 angles. That proves to be angle side angle, and when you're using this, you could say, in this case, that triangle GBH is congruent to triangle KPN by angle side angle. And the last and final postulate, so of these 4, we have the angle angle side postulate, abbreviated as AAS. And this says if 2 angles and the non-included side of one triangle are congruent to 2 angles and the non-included side of another triangle, then the triangles are congruent. If we look at our diagram, we have an angle congruent to another angle. We have our second angle, and then this side is not between those angles. So compare these 2 diagrams. In this diagram, the side is between the angles. You have an angle, a side, an angle. In this diagram, you have 2 angles and a non-included side. So I can continue to explain this, but ultimately you guys have to visualize. So you have to be able to look at this and you have to see which one you're dealing with. Are you dealing with angle, side, angle, or angle, angle, side? And you have to recognize the difference between the two. So in this last, the fourth example, we could say triangle CDM is congruent to triangle XGT by angle, angle, side. Okay, now let's take a look at our examples. So we are given diagrams and you need to prove if the triangles are congruent. If so, we write a congruent statement and we justify our answer with definitions, theorems, or postulates. So if I look at this first one, number 1, I have two triangles within a larger figure. I see a triangle here and I see a triangle, oops, here. So one thing that you have to be prepared to recognize on a lot of models is that if you have two triangles that share a side, obviously that side is congruent between the two triangles because they both share that side, so it is equal. So if I look at this model, I see that I have side BC congruent to side BF. I can see that I have angle DBF congruent to angle DBC. And then I see that both triangles share this side, which means it is congruent between the two. This is going to be side, angle, side. My two sides are the sides or the rays of the angle. So if I list off my information, which you don't always have to do, but I'm just going to do it on this one so I can write what I'm saying. I know that BC is congruent to BF. That's my side. I know that angle DBF is congruent to angle DBC. That's my angle. And I know that BD is congruent to itself because it's within both triangles. And that would be a side. So if I was to read this, we would have side, angle, side, and that is your answer. When we write our congruent statement, we're going to write it as triangle CBD is congruent to triangle FBD by side, angle, side. So a reminder from yesterday's class, this here, that's your congruent statement. This here, that's your reason. Okay, so we just looked at the side, angle, side example. Before I go over number 2, let's just quickly review the 4 postulates that we could potentially use. We could use side, side, side. That was the first one we went over. The second one we went over was side, angle, side, which we just did an example of. Then we went over angle, side, angle. And the fourth one that we reviewed was angle, angle, side. Those are your 4 choices. Okay, you cannot use anything else. You can't make up different postulates. You have these 4 choices as your answer. Okay, number 2. Number 2 is 2 triangles. There's one previous postulate that we need to use, so something we've learned before, and that's vertical angles. So vertical angles are congruent, and you're going to want to utilize that in this model because after you utilize or indicate that you have vertical angles, you have an angle, and a side. Angle, angle, I said that backwards. Angle, angle, side. So we could prove that triangle CAB is congruent to triangle DAE by angle, angle, side. And that will be my statement. Number 3. Number 3 also has two triangles. Number 3 appears to be staggered, but one thing I want everyone to notice is these two parallel marks. We haven't gone over parallel lines in a little while, but they do still apply. So we have these two parallel lines, and we have a transversal that cuts between them. It's this line here. So remember that all of your parallel lines theorems will apply to this problem. And I see one that right away stands out to me. That would be alternate interior angles. These two angles here are congruent by the alternate interior angles theorem. I also want to point out that both triangles share this side, so we know that side is congruent. If I highlight and say out loud, we have angle, angle, side, or angle, angle, side. So I can say that triangle MNO is congruent to triangle STV by angle, angle, side. And number 4. Number 4 should be very quick to solve because recall that all 4 postulates that we went over, all 4 of these have 3 parts. So they have a combination of 3 pieces between sides and angles. If we scroll down to number 4, all we see here is one angle and one side. These triangles are not touching, so they do not share a common side. They do not share a common angle. We don't have vertical angles. We have no other info on these two triangles, and we only have 2 parts of information. We only have one angle and a side. That's only 2 parts or 2 pieces of info. So we do not have enough info to solve this. And that would be your answer. Okay, I want everyone to press pause on their video. Please try to complete the on your own section by yourself, and then come back and my answers will be here. If you would like to see more examples, there are 2 extra videos posted on my website that have very good examples for problems like these. So please take a look at those if you feel like you need more of an explanation or if you just want to see more work done out. Let me know if you have any questions, and have a great day.